Hello science fans! Did you know that there is evidence that shows some regions in the planet are experiencing more typhoons now? These regions include the western North Pacific, where we can find the Philippines, Japan, and China. And data has shown us that the frequency of typhoons in this area has increased by at least 15%. While the North Atlantic is not typically associated with typhoons, there has been an increase in the number of hurricanes and tropical storms in this region also in recent years. And the South China Sea is also experiencing an increase in typhoons, particularly in the later part of the typhoon season. And in recent years, it's actually difficult to identify a single greatest typhoon, as there have been so many devastating storms that have affected different countries in different ways. But one example of a particularly destructive typhoon is Super Typhoon Haiyan, which struck the Philippines in November 2013. This storm is one of the most powerful typhoons ever recorded, with sustained winds up to 195 miles per hour and storm surges as high as 50 feet. The typhoon caused widespread devastation in the central Philippines, particularly in the city of Tacloban, where thousands of people were killed and many more were injured or displaced. Other examples of particularly destructive typhoons include Typhoon Morakot, which struck Taiwan in August 2009, causing widespread flooding and landslides that killed nearly 700 people and cost $3 billion in damage. There's also Typhoon Haitang, which struck China in September 2005, causing severe flooding that killed more than 500 people and cost $3.6 billion in damage. And there's Typhoon Bopha, which struck the Philippines in December 2012, causing severe flooding and landslides that killed more than 1,000 people and cost $1.7 billion in damage. But what causes typhoons, and why do they seem to be getting stronger? But before we answer those questions using science, hello to our new viewers. My name is Chona and I'm your resident Filipina scientist. I'm a researcher who has seen how natural disasters have affected our ecosystems and have caused a lot of loss to our fishers and farmers. I teach subjects in biology and environmental science that I hope can help the next generation be more prepared for the challenges brought about by climate change. And SHE-ensya is my science communication channel where I talk about how science can help us live better in our planet. So, let's talk about typhoons. Typhoons, also known as hurricanes or cyclones, depending on the region, are large tropical storms that form over warm ocean waters. They are caused by a combination of factors, including warm ocean temperatures, high humidity, and low atmospheric pressure. Specifically, typhoons are formed when warm, moist air over the ocean rises and cools, which causes the water vapor in the air to condense and form clouds. This process releases heat and causes the surrounding air to become warmer, which then causes them to rise even further. As the air rises, it creates an area of low pressure near the surface, which causes more air to flow in from the surrounding areas. This cycle of warm air rising and low pressure forming creates a spinning motion that can turn into a powerful storm. But did you know that human activities can also contribute to the formation and intensity of typhoons? Specifically, climate change has been linked to the warming of our sea surface temperatures, which will provide more energy to the formation of more intense typhoons. So, human activities such as the contribution of greenhouse gases, deforestation, and urbanization affects the local climate and climate change, and thus contributes to the formation of typhoons. But even if our actions has contributed to climate change, and thus to the increase in frequency and intensity of typhoons, this doesn't mean that we can create artificial storms or typhoons just yet. Typhoons are still a natural phenomenon that are caused by specific atmospheric and oceanic conditions, and they require a complex interplay of factors to form and intensify. So, while it is possible to create strong winds and storms in a laboratory setting, it is not yet possible to create a man-made or artificial storm in the real world. In the Philippines, typhoons are categorized based on the tropical cyclone warning signals of the Philippine Atmospheric, Geophysical, and Astronomical Services Administration or PAG-ASA. The warning signals are divided into 5 levels, each corresponding to a range of wind speeds and associated impacts. So, signal number 1, for example, has wind speeds of about 30 to 60 kilometers per hour that is expected to arrive within 36 hours. And this can cause damage to some crops and trees. Signal number 2, on the other hand, has wind speeds between 61 to 120 kilometers per hour, which is expected to arrive within 24 hours. And this causes damage to high-risk structures such as small houses, trees, and crops. While signal number 3 has wind speeds of 121 to 170 kilometers per hour that can arrive within 18 hours, which may cause extensive damage to high-risk structures, disruption of power and communication services, and widespread flooding. Signal number 4 has wind speeds of 171 to 220 kilometers per hour, which is expected within 12 hours, which may cause catastrophic damage to high-risk structures, widespread power and communication outages, and severe flooding and landslides. And finally, signal number 5 has wind speeds higher than 221 kilometers per hour that is expected within 12 hours, which may cause widespread devastation and destruction, including the possibility of storm surges. Now, PAG-ASA uses a combination of satellite data, weather models, and on-the-ground observations in order to identify and give out the proper warning signals. These warnings are critical for helping communities prepare for and respond to the impacts of typhoons, including evacuating to safer areas and securing property and infrastructure. As scary as typhoons are, especially with climate change, it doesn't mean that we are powerless against this powerful natural phenomenon. Governments can adopt and enforce building codes and infrastructure standards that are designed to withstand the high winds, heavy rainfall, and storm surge associated with typhoons. We should also start working on better land use planning and zoning policies that help minimize exposure to typhoon hazards. This can include measures limiting development in high-risk areas such as coastlines, the protection of natural ecosystems that protect us from typhoon damage such as mangrove forests, and also the development of green infrastructure that can absorb the heavy rainfall and prevent flooding. Early warning systems are so important to allow communities to prepare for and mitigate the impacts of typhoons. But can we already predict when a storm is coming? With the help of science, yes, we have the means to guide us regarding the coming of typhoons. In fact, there's a whole scientific discipline dedicated to it called meteorology. Meteorology is the scientific study of the Earth's atmosphere and the processes that occur within it, including weather patterns, climate change, and the impacts of natural phenomena such as hurricanes, typhoons, and tornadoes. There are several tools and techniques that meteorologists use in order to predict typhoons, and here are some of them. Meteorologists use satellite imagery to track the development and movement of typhoons. Meteorologists also use computer models to simulate the behavior of the atmosphere and ocean. Ocean buoys are floating devices that can measure sea surface temperature, wave height, and wind speed. Some meteorological agencies use aircraft to fly into typhoons and collect data on wind speed, temperature, and other atmospheric conditions. Doppler radar is a type of radar that can detect the motion of rain in the atmosphere. Overall, a combination of these tools and techniques is used to help predict the coming of typhoons. However, it is important to note that predicting typhoons is not an exact science. It still is a very complex natural phenomena, and there are a lot of uncertainties that prevent us from being 100% accurate in terms of predicting where the typhoon is going and how intense it will be. But what do you think? What are some of the scariest typhoons that you've experienced? How can we help the vulnerable communities survive and thrive despite these changes in climate? Let us know your thoughts in the comments section below.